You say that like that's an outrageous thing, but I would 100% you would do that, right? Like you're just like as if just like no, that makes sense.
That's what I do.
There you go. Okay. Guys, we've actually already talked about this. We've talked about the definite integrals. I decided to show you this the other day. Can I remember what's the difference between a definite and an indefinite integral?
Yes.
Yep, so what happens to the c value in a definite integral? You don't know what the c value is, but something happens to the c value. Disappears every time. So we don't bother to input plus c on a definite integral. How do I know if something is a definite integral? On the integration symbol, it'll have the bounds of it on the integration symbol. That means that it's a definite integral. Or another way of saying that would be a bounded integral. Do you need to hand that to me, guys? I think you should bring it up here. You can grab it back at the end of the lesson.
And that means
There will be no c value, no. Okay? Yeah, we just don't bother. Makes our lives way easier. Then to solve it, all we need to do is sub in the upper bound to our derivative. To our integral. I keep on mixing up derivative and integral today. We sub in our upper bound b to our integral. We sub in the lower bound, and then we subtract them. And then we're done. So remember, what does an integral find? Under the curve. So this really is area under curve from x equals a to x equals b. So if I was to visualize that for you just off to the side, let's imagine this is my function. Looks something like that. If I was to draw a line at a and to draw a line at b, if I call this one fx, the shaded area you could find by the integral from a to b of fx dx. That's all we're doing. We're finding areas. We will look shortly at we can actually find the area between two separate functions as well. It's not too difficult, but that's what we'll be doing. So, use the above rule to calculate the definite integral from 0 to 2 of 3x squared with respect to x. Remember, that's all the dx means with respect to x. So, the integral from 0 to 2 of 3x squared dx equals, what is the integral of 3x squared?
it's 3 divided 3.
3x cubed divided by 3, because we add 1 to the power, we divide through by the new power, the 3's will cancel. Now for this one, I'm going to keep the c in, just to show you why it disappears eventually. So plus c. Now, when we do these definite integrals, because remember we have those bounds, we keep brackets. We normally do square brackets for these ones, actually. And we just write the bounds. I don't know why we do it this way, but we then write the bounds on the right-hand side. Sorry, not a and b. What's my lower bound? And then 2. I'm not quite sure why we go from having it on the left of the function to the right of the function, but that's just the way it's done. So then all we do is we sub in our values, the upper limit, and we do then minus the lower limit. Okay. So we've got, instead of x cubed, what am I going to have in my first bracket? 2 cubed. And instead of my instead of x in the second bracket, 0. Once you've subbed in the things, you don't worry about the square brackets. The square brackets are mostly there to remind you to keep your bounds in mind.
Cube.
It would be cubed. So my first bracket would be 8 plus c. What is 0 cubed? 0 plus c. So that ends up being 0 plus c, which is c. And then we're taking that c away. Yep. Yes, one.
So that's 8 units squared.
Yeah. It is, Miss Cross. So therefore, we wouldn't normally write this, but just because this is our first one, we're going to say that there is 8 units squared of area between x equals 0, x equals 2, the function fx, and the x-axis. So when we do this integration, guys, we always have 4 boundaries. We have the left bound, the right bound, where x equals, in this case, 0 and 2. We have the underneath bound is always the x-axis. So that's always the bottom of our area. And the top of our area is the function. So that area that we found is, if I was to draw it, x cubed, it looks something like that, I guess. So remember when we did that trapezium rule? And we could sort of like approximate the angle fairly well. What integration is basically doing is it's doing the trapezium rule, but infinity times. So it's the same thing as if you did infinity trapeziums. So each one is what we call arbitrarily small to the fact that it doesn't have a width anymore. We're just basically finding the height of the line at that point. And then moving, an infinitely small amount to the next spot, finding the height at that point, which is essentially just a trapezium. And then it adds them all together, and that's how we find that.
H approaches 0 with that.
That's the exact same thing that we're doing here, but we did that for derivatives. We're doing the same process here, but for area. I just haven't explicitly shown you the h equals 0.
By the end of the year, something to do over the holidays, just got like all the different things, just an example or 2 of each.
If I have some time, I'll see what I can do. Okay. Are there any questions on the definite integral stuff, guys?
Indefinite just plus c.
Sorry?
Indefinite just plus c.
Indefinite, no bounds, plus c. If you forget the plus c on an exam, you will lose marks.
Just quickly.
Could you maybe do it like medium speed?
Medium's fine. On that third line of writing, you have brackets, 2. You know what I mean?
Uh-huh.
Where do you get all that from?
The bounds.
2. Okay.
So the bounds are from 0 to 2.
Yeah.
So we take our upper bound 2 and sub it into the function.
Yeah.
Then we minus the lower bound subbed into the second function.
Always minus.
It's always minus. Okay. We're going to do this one both with a trapezium rule and with the definite integral. Which do we want to do first? Definite integral. So, area with a def int would be the integral. What's my function? X plus 1. What are my bounds? 2 and 4. So dx. What's the integral of x? What's the integral of 1 plus x? Now,
that would be like divide 1.
Yeah, technically divide 1, but I don't worry about writing that in. I'm going to leave c. C's dead to us in definite integrals from now on. It's always going to cancel every single time no matter what, so we can ignore it. But because we're doing a definite, I need to chuck in me brackets and put 2 to 4. Okay. What's my next step? Sub it in. So we'll have 4 squared over 2 plus 4, close brackets, minus 2 squared over 2 plus 2. 4 squared is 16. Divided by 2 would be 8.
4
minus
2 plus 2. 4 and
So if you do 8 plus 4 is 12, minus 4 is 8 units squared. If we do the area via trapezium,
what was that say? A plus B and 2 A's.
sorry? Sure. The trapezium rule from memory is area equals width on 2 brackets E plus 2M. It's width on 2, isn't it?
Yeah.
Yes. Okay. We're going to need to find what E is, and we're going to need to find what M is. How many slices should we use for this particular 2? Do you reckon? We can get away with using 1. Like, the shape is a trapezium. Putting in 2 slices is just going to make us do double the amount of work. Like, we can do it in 1. So I'm just going to make a note, because there's only 2 slices. Width equals 2. Yes?
Yep.
That means M equals 0, correct? Because midpoints. There's no midpoints because we only have 1 slice. And then E is just going to be the function evaluated at the beginning, 2, plus the function evaluated at the end, 4. So that'll be x plus 1, so 2 plus 1, plus 4 plus 1. 2 plus 1 is 3, 4 plus 1 is 5, equals 8, so area equals 2 on 2, bracket 8 plus 0, which ends up being 8 units squared. What a coinky-dink. Sorry, I should have gone a more medium speed.
Yeah. I didn't realize how easy the equation was. I put it into my tech, but that's
Yeah. So remember the endpoints and midpoints, you just sub in the x value that they occur at to your function, and that'll give you the value of your endpoints and midpoints. The only reason I got you to do this one, guys, is just to see that they are the same thing. We're doing an approximate, the trapezium is your approximate area, your definite integral is the exact area.
So if we're asked to do it by this principle, when we ask to use
Trapezium rule.
So like we went through about what?
Maybe one question in the exam might be like, use the trapezium rule to solve this. It's actually, I think, pretty common. There's been like one question.
3 different rules before we even did the trapezium. We did left box, right box.
Yeah, you'll never need to do left box and right box. Just trapezium. And I believe the trapezium rule is on your formula sheet. Okay, Questions, comments, concerns on that one before we move on? No.
Yeah.
Yes. So you will, and I know I was looking at last year. Did I have general methods last year? No.
General.
It was the year before. I remember when I was doing revision for external, trapezium rule popped up on a bunch of multi-choice questions, and it's like using, what would the trapezium rule for this look like? And you had to like pick the right one. So you do see trapezium rule in externals as well. Okay, calculate this using definite integrals. Do you guys reckon you need me to go through this with you, or do you reckon you can have a go at these?
You guys should probably skill.
Okay, I'm going to do a line of working out every 20 seconds. See if you can get there before me.
You explain it.
Equals. So, it's a definite integral because it has bounds. So I'll put my brackets here, my square brackets. Correct. No C. And I've just got to integrate what the function is telling me to do. 3x squared plus 5x. So to integrate 3x squared, I add 1 to the power, and I divide by the new power. 3x cubed divided by 3. Same thing with 5x. I add 1 to the power, I divide by the new power.
5x.
Plus 5x squared over 2. And then I close my brackets, and because it's a definite integral, I don't need that C, but I do need to include my bounds, 0 and 3. So now, I'll just note that I can cancel the 3 and the 3 there. So that gives me my function evaluated at my upper bound minus my function evaluated at the lower bound. So that gives me, and my upper bound is 3, so that gives me 3 cubed plus 5 times 3 squared over 2. And my other one, it'll be 0 cubed plus 5 times 0 squared over 2. Because we're subbing in my upper bound to x. My upper bound is 3.
How come you didn't do that? Oh, yeah, you did.
Okay, 3 cubed is 27. 5 times 3 squared, 5 times 9 is 45, over 2 is 22 and a half. So that's 27 plus, what did I say? 9 times 5 is 45, 22 and a half. Minus 0, because that all cancels out to 0. So that would give us 49.5 units squared.
Yeah.
Questions, comments, concerns? It's much nicer than indefinite integrals, I gotta say. Yeah, the ones with plus C. Okay. So, for this one, equals 4x minus x cubed on 3. From 0 to 2 equals 4 times 2 minus 2 cubed on 3 minus 4 times 0 minus 0 cubed on 3, which that whole end one ends up being minus 0, so whatever. 4 times 2 is 8 minus 8 thirds, which would give us 24 on 3, which would be 16 on 3. You make them have the same denominator. So to make 8 into thirds, you make it over 3. Then because you've divided by 3 on the bottom, times 3 on top, so you get 24 over 3. Then you just take 8 away from that, which should be 16. So 16 thirds. Units squared. Okay. Questions, comments, concerns? 16 thirds, so that would be 5 and 1/3. Have I made a mistake? No. Where have I lost you guys? Yeah. Okay. For this next one, guys, it's asked you to sketch the functions as well. So to do this, I'd just like you to do it in your graphics calculator. Now, I would pop mine up on the screen, but because my computer's restarted, I'm going to have to do some stuff to. Yep. Math menu as well. It's actually a really good habit. I might just pause quickly, guys. If you go to your graphics calculator, it is really good at calculating definite integrals. So if you go on math and go down to the bottom, the number 9 can say fn int, so the finite integral, and it'll give you a little display where you put in your lower and upper bound, your function, and then what variable you're using. So for that one that we just did, we had from 0 to 2 of 4 minus x squared dx, and it gave me 5.3333, which if I go to math, put that as a fraction, 16 thirds. Very handy. Questions, comments, concerns? 1,000-yard stairs. You can do that in Tech Active. I would encourage you to do that in Tech Active. If you don't do that in Tech Active, you're wasting time. Remember, everything I do when I write Tech Active papers is knowing that you can do all the calculations that way. That being said, it's very common that, a Tech Active question might say something like the area under this curve between, 2 bounds is this, and it might give you like one of the bounds, and then you need to work backwards to figure out what the second bound was from knowing the area ahead of time. Okay. Sketch each of the functions, find the area under the curve for the given domain. This one, I know that x squared is like a smiley, and plus 4 on it will just move it 4 up. So x squared plus 4 will look something like that. Because I've worked with these functions for many years. You should. What does x squared look like? And any function, if it just has like a plus or a minus at the end of it, it just gets shifted up or down. That's all the plus or minus at the end does. You'd have to have like you'd replace the x with a bracket, and it would be like x plus something, and that all shifted left and right a bit. Negative x squared. Square root looks like that. Okay. And we want to find the area between 0 and 1. So we want to find this area in there. So let's do it. So the integral from 0 to 1 of x squared plus 3 dx equals equals x cubed on 3 plus 3x from 0 to 3 equal... Oh, sorry, 0 to 1. Right, you are. Which would be 1 cubed on 3 plus 3 times 1 minus... What are you noticing when we have 0 as a bound, guys? Is that always going to be the case? Very rarely from this point on will that be the case. Generally, yeah. Generally, there is something in that second bracket. And a lot of the time it ends up being a double negative, just for some forewarning. So we end up with minus 0, so we end up with 1/3 plus 3 minus 0, so that would be 9/3, 10/3 units squared. Sorry? How many thirds are there in 3 wholes? 9. And then I'm adding 1/3 to that. Okay. I only have 10 minutes left, guys, so I'm actually going to leave that last question. It's just the same as we've been doing. The only difference is that, yeah, it won't have 0 as the second bracket. I suppose we may as well do it. We'll do the textbook work next lesson. I'm going to have to start giving you some Thursday summary sheets again for homework. Ryland's excited. If you plot x plus 2x squared in your graphics calculator, what does it look like? Thanks, Ryland.
Did that help?
I think that was like the first joke that Ryland's ever told us to make me laugh. Did he say that? A line on a graph? Good job.
Well, at least he got one person. Your bounds are not very good there. Because our x values are from 1 to 4, maybe go 0 to 5. It should look more or less like a regular quadratic, but because it's got the plus x, it'll be like going up even steeper than normal, would be my guess.
Just a big dude.
So you got x plus 2x squared. If it was just x squared, it'd just be a smiley. 2x squared means it's a steep smiley. And because you're plussing x to it, every time you go across 1, you're going up by 1 as well. So it's like adding that on. So it would look something like that. And we want to go from there to there, 1 to 4. From 1 to 4 of x plus 2x squared dx equals x squared on 2 from 1 to 4. We get 4 squared on 2 plus 2 times 4 cubed on 3 minus 1 squared on 2 plus 2 times 1 cubed on 3 equals 4 squared on 2 is 8 plus 2 times 4... 4 cubed is 64.
You keep it on 3 because it's
Well, it's 2 times 64, so it'll be 128 on 3. Does 128 be divided by 3 at all? No. 128 on 3 minus 1/2 plus 2/3. If I combine that first bracket, 8 over 3, sorry, to get 8 over 3, times it by 3, which would be 24. 128 plus 24 would be something. 128, 30, 52. 152 over 3. Does that become a nice number?
Beautiful.
No. 1/2 plus 2/3 would be 3/6 plus 4/6, which is 10/6.
Yeah.
Uh-huh. To simplify those ones, I get them both over 6, so that would become 304/6 minus 10/6 equals 294/6, which I think is a actual good number. 49.
True.
30.
Didn't it take 7?
Take 10/6.
You didn't calculate.
To do 294 divided by 6. Hold up.
So,
I might have made a mistake. Let me check.
that'll
It
be
should
one
be-
like,
1/2 plus 2/3. You would have 4/6. Sorry, you would have 3/6 plus 4. Oh yeah, so that'd be 9. Oops. Yeah. Oh, 7/6.
Oh,
There you go. 49.5 units squared.